Let's begin. Today is October 21st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 9, 11, 16, 18, and 20. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should triangle be greater than 3? Criteria card B takes a look at our 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at our first and middle digit, triangle and square, and compare them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card D will again take a look at our 3-digit solution, except this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E will take a look at our 3 digits, triangle, square, and circle, add them together, and the Turing Machine will let us know whether that sum total is an even quantity or an odd quantity. And finally, criteria card F again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. And there are 3 cases. One where there are no repetitions among the 3 digits in the code, as in the example 125, or the Turing Machine could let us know that there's a double number, meaning there's a single digit repeated once, as in the example 112, or it could be a triple number, a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards that we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card D, finding the ratio among even and odds. So let's go ahead and test criteria card D. Okay, so the Turing Machine does approve of my choice in 314. Notice that I do have 2 odds to a single even, and the Turing Machine approves of that. So it's true that there should be less even than odds. So let's go ahead and type that up in our notes in section D. And again, we'll say that there are less even than odds. So what does that tell us? It tells us that there's at least a minimum of 2 odds and a single even, or it could potentially be an all-odd solution. So let's go ahead and test criteria card E. Okay, so in this case, the Turing Machine does not approve of my proposal. So in criteria card E, we are adding up all the 3 digits. So let's go ahead and do that. So 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, but the Turing Machine does not approve that. So it's letting us know that the sum total of the 3 digits needs to be an odd quantity. So let's go ahead and type that up in our notes. So we'll say that triangle plus square plus circle should be an odd quantity. And so again, taking into consideration what we discovered in criteria card D, we do have a minimum of 2 odds. So if we add up those 2 odds, when you add 2 odds up, you get an even quantity. But if you want a sum total to be odd, that means you have to add a third odd. So in fact, our solution should be an all odd solution. Okay. So yeah, we do need 3 odds in order for the sum total to be odd, assuming that you have a majority of odds. Okay, well that means that we can cross out all of the evens in triangle, square, and circle. So let's go ahead and do that. And so we have an all odd solution. All right, now let's actually test criteria card F, and see if we have any kind of repetition. Okay, so the Turing machine does not approve of my choice. Again, we are talking about repetitions and duplicate digits. So all we can say is, since my proposal has no repetitions, we just exclude it from consideration. So we are dealing with a possible double number or triple number. So let's go ahead and type that up in our notes. So the solution is a double or triple number. Okay, now is there any way to exclude perhaps it being a triple number? Are there any clues? Well, I don't see that among the remaining criteria cards. I just don't see it. So I think we still have to consider the fact that it might be. Okay, well, that does it for this round. We have completed our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So if we take a look, we did not test criteria card A, comparing that first digit to the number 3. We also did not test how many 3s there could be in our solution. And of course, we did not test how triangle and square compare to each other. And it really boils down to, those first 3, the top row of our criteria cards, and to a lesser extent, criteria card F, since we don't know for sure if it's a double or a triple. So one thing that comes to mind is, if there were no 3s from criteria card B, if there are no 3s, then potentially you could be dealing with, a double 1 or a double 5, or perhaps maybe even a triple. So that's something to consider, maybe if there were no 3s. And we are comparing triangle and square, the first 2 digits. And also notice that although criteria card E does have a circle in it, it's somewhat indirect. So it seems that circle would have to be forced into, whatever odd value it will be. And it could be that might be the other double, whether it's, 2 1s or 2 5s. So let's see, how would that work if it was the other double? How would that work? So triangle will obviously let us know, what its value is, now that we've sort of limited to being an odd. And then the square digit will be, greater, equal, or less than the triangle digit, but there's really nothing that really stands out as, oh, it's got to be a 1 or it's got to be a 5. I just don't see that. And of course, we also can eliminate the true possibility of using each one individually, right? There are repetitions. So let's see. I don't know. Could it be a triple number? Somehow triangle, you will find out what it is, and maybe they're equal. Triangle and square, they could be equal. And then maybe it is a triple number. I'm trying to see. Or it could be that the first two are equal, and because there are no 3s, it would have to be forced into that other odd digit. Or it could be that there is a single 3, and that's how it's going to be determined. So let's see. So I think I'm going to pick triangle 3. And, well, triangle 3, ooh, that's interesting. Could we have 2 3s? Well, I think let's see, is it safe to say that you can't have 3 3s? Yeah, I think you can say you can't have 3 3s because then, of course, triangle would equal square, or, of course, triangle would be a 3. So I think we can cross out the possibility of there being 3 3s. Now, you still could have 2 3s, but if you had 2 3s, yeah, I guess you could determine what square is from criteria card C. Yeah, I could see something like 3 1 3 or 3 5 3. That's a possibility. So yeah, let me go ahead. Well, yeah, let's do 3 5 3. I really don't know. Let's go ahead and try that. 3 5 3. Okay, well, the risky part is criteria card B, so I'll leave that for a little later. So let's go ahead and test criteria card A. Okay, so it's not a 3. So what we'll say is that triangle must be either less than or greater than 3. So we'll say triangle is less than or greater than 3. And we will cross out that middle 3. Okay, let's now test criteria card C. Okay, so it's not true that a square is greater than 3, or better put, triangle is not less than square. 3 should not be less than 5 as far as picking values. So what we'll say is that triangle is either equal to or greater than square. So that was criteria card C. Again, we'll say that triangle is equal to or greater than square. Okay, and yeah, I think we can cross out obviously the 5. Well, no, technically we can't cross out the 5 even though it is bigger because it could still be equal. It could be 5, 5. So yeah, I don't see how we could cross out anything because of that. Well, that's not good. And I do anticipate 2 3s as being invalid. But let's go ahead. Well, let's see. Should we test it? We could skip it, but I guess the question is, okay, well, let's talk about it. So we do have 2 3s, and so the only possible solutions, if there were 2 3s, is that it would be 1 3 3 or 5 3 3. And I guess technically I could see, well, let's see. Well, it would be 1 3 3, right? Because you can't have, or wait, hold on. No, it couldn't be. It would have to be 5 3 3. It would have to be 5 3 3 because triangle needs to be equal or greater than square. So yeah, it would be 5 3 3. So there's only one possibility for having 2 3s, and that would be 5 3 3. So let's see. Strategy wise, if it fails, I'm still going to have to go to a third round. If I go to a third round, could I still somehow deduce or figure out that the solution should be 5 3 3? Well, if I pick well, let's see. Could 5, yeah, again, triangle could be 5. And yeah, how about 1? Could triangle be 1? Because of the equals, yeah, I suppose it could be 1 1 5. Yeah, I'm not sure. Well, at least we know it can't be a triple number with 3s. So could it be all 1s, all 5s? So let's pretend there are 0 3s and triangle and square are either equal to each other or triangle is greater. Well, we could, let's see. I guess we could test criteria card F and know for sure if it's a double or a triple instead of the 3s. Is one better than the other? Well, the triple versus double is general, whereas the 3s would be specific. I think I'm going to take a risk, and I'm going to test criteria card F. I think I would rather know for sure if it's a double or a triple. Okay, so, well, let's see. Again, if it's a let's see, if it's a triple, you know what? I think we can deduce it can't be a triple, because if it were a triple, then of course, almost the same reason that I use for criteria card B. If it's a triple, then of course we'd know triangle were equal to square. Not so much criteria card A, but we would know that those two would be equal for sure. And so it would make it irrelevant. So yeah, I think we are dealing with a double. The question is it a double 3 or not? Let's see. Okay, so we are dealing with a double. So I'm gonna say right now, I'm not gonna cross it out, but I'm gonna say, yeah, I think it's safe to deduce that it is a double. Okay, so the question is it a double 1, double 3, or double 5? So let's see. So if I have no double, I know I don't have triple threes. If I have no double threes, could I still have a single three? Or no three? And so the question is, which ones are equal? It would seem the easiest to be the first two, triangle and square. And if that's the case, I don't think it could be 5, 5. Well, no, it could be 5, 5. There is a 3 or there isn't. Yeah, you can make that distinction. And actually, that seems to be the only plausible if the first two were equal. So, yeah, so I think I'm gonna 3, 4, 5, 6, 7. I'm gonna take a risk and I'm gonna go to the next round. And I'm gonna pick either 5, 5, 1 or 5, 5, 3. All right, so I'm gonna not do my third test for this round. And so let me go ahead and I'm going to pick 5, 5, 1. Okay, so the whole reason for that was to test definitively whether the first two digits are equal. So let's go ahead and test C again. Okay, it is true. So let's go ahead and cross out having a little bit of difficulty here. Nope. There we go. Okay. So we know that they're equal. So what does that say about, I think we can cross out that middle 3 because it can't equal with its triangle value. And could we have 1, 1? I don't think so, since triangle cannot be smaller. Okay, and again, we are sort of deducing that it's a double number. So the question is there a 3 or not? So let's go ahead and test criteria card B. Okay, and it also approves of the absence of 3. There are no 3s. So let's go ahead and cross out the 3, the last 3. And again, it has to be 5, 5, 1. So, yeah, so let me go ahead and cross out the 1 in triangle and the 1 in square and the 5, the last 5. And again, we are deducing that it's a double, so 5, 5, 1 looks to be the solution. Well, actually, before I type that up, let's go ahead and say the solution has no 3-digit. Okay, so yeah, it looks like the solution should be 5, 5, 1. Okay. Oh, I guess I did not. When did I test? Oh, I guess we're deducing that triangle is also greater than 3. Yeah. So we're deducing triangle is greater than 3, and we're deducing that it's a double. Well, let's go verify the solution of 551. Five, five, one. No. Oh, wow. Could it be a triple number then? What happened? The sum is odd. Well, obviously the game is lost. Perhaps, well, the only other thing I can think of, could it be all fives? But that makes no sense. Can't believe it could be a triple number. And it did say no threes. That was criteria card B. Okay, so definitely not all threes. Could it be five? Well, no, and C is that they're equal. Five, five. How can it be a triple number? Five, five. Triangles, five, five. Well, let's, I guess, test criteria card A. And we may have to go to a fourth round. Let's see, E is established. I guess F is still up in the air, but I'm pretty sure it's a double. Let's test criteria card. Yeah, it can't be 115. Wait. Yeah, that's C. Yeah, it can't be 1. Oh, wait. It could be 115. Because there we'd be comparing circle. Ah, yeah. Okay, so yeah, let's go ahead and test criteria card A. Yeah, it's not greater than 3. Okay, so let's go ahead and cross this out. Okay, and A established that it is not greater than 5. So, or sorry, greater than 3. Right? That was A. Did not like the fact that I chose a 5. And so, yeah, triangle should not be greater than 3. So it has to be less than. That means this is not a 5, which would mean that it would have to be less than, and the only less than is 1. And they are equal, so that means square has to be 1. And so let's cross out the 5. And because there are no 3s, let's cross out the 1 in circle and uncross out the 5. So it looks like it should be 1, 1, 5. Wow, how unfortunate. Well, let's go verify. So 1, 1, 5. There we go. Okay, well, it's lost, but let's go see how did we do versus the Turing machine. We did do 8 tests. Wow, that's a pretty large number. Well, let's go check. Okay, so let's see. So in the first round we did DEF, and we got the first one correct. And then we did AC in the middle, and then we did all ABC in the third. And so yeah, D was correct, and then BC. All right, let's see if I can type that up accurately. So DEF, D was correct, E and F were incorrect, A and C were incorrect, and then, I think A was incorrect, and B and C were both correct, or only C? Let's go see. Yeah. Okay. Well, how did we do? Wow, we still would have tied. Ah, how unfortunate. Well, yeah, I made a very bad logical conclusion that triangle was 5, when in fact I had not tested it. I guess what really threw me off was the circle wasn't really being compared. And I think that's what kind of tripped me up. Somehow I had in my mind criteria card C, but we weren't really comparing circle. As I mentioned at one point in the video, circle would default to the other digit, and it could have been 1 or 5. So okay, well, lesson learned. These mistakes will happen from time to time. We just have to keep going. Well, how did you do? What criteria cards did you choose? And was it, maybe a better approach? Share your ideas in the comments. If you liked the video, please give it a thumbs up. And of course, don't forget to hit subscribe to be notified. Well, until next time, have a great one.